We're not talking about spraying just because of a cosmetic blemish. This is a serious economic pest. For example, who's going to buy this? Nobody. It's unsaleable. It's not just ugly, it's unsaleable. So this pest must be controlled to have commercial apple production. And in the past century, we've relied on pesticides. That's been the tool that people have had to try to grow apples successfully. In Washington, we started out with lead arsenic in the late 1890s through, say, 1940. Well, lead and arsenic are both natural compounds. Lead arsenate, I don't think is, but you can see they're both naturally occurring in the environment, highly toxic and highly persistent. They don't break down. Lead is just an element. It stays there. So we loaded our soils with lead arsenic for 30, 40 years. The insect became resistant to them, and the soils became contaminated. So along comes World War II, the development of DDT. And at that time, the switch from lead arsenate to DDT was a dramatic step forward in sustainability. So try to think of that. If you're out there spraying lead arsenate, which is what people did, with no worker protection, that was nasty. And DDT comes along, and it was a miracle. Well, lo and behold, we found 20, 30 years later some potential problems with DDT and accumulation in the food system and bird mortality. So we said, okay, DDT didn't work out. Now along comes another material, these organophosphate pesticides. Not persistent in the environment, highly toxic, but not persistent. So again, at that time, the switch from DDT to organophosphates looked like a very reasonable step forward in sustainability. Lo and behold, another 20, 30 years later, organophosphates, they interfere with the cholinesterase in our nervous system. They're not particularly good to eat, to ingest, to be exposed to. So we need to move on, and we're moving on now to other products called insect growth rate. Still a pesticide, kills the pest, but these disrupt the natural metabolism of the pest and basically stops it from going through its molting things. It has no toxicity to mammals or other organisms, just insects. So this is kind of a pretty typical evolution towards sustainability. We try to learn from what didn't work, and hopefully the next one will. But along with this progression was the discovery of pheromones, which are chemicals that insects put out to communicate with one another. And the idea of trying to figure out how the codling moth communicated and the ability to potentially affect that communication to get some pest control was commercialized in the mid-'80s into the '90s, and it was found to be pretty darn effective. Once that happened, we started to see very widespread adoption, and I'd say we're probably above 70%. It may be 90% for all I know at this point, of the orchards in the state are using this technology. So once the technology is proven and it can work, growers are willing to adopt these things, and I think that's something a lot of folks, particularly in cities, don't understand. The growers aren't wedded to using nasty, horrible chemicals. Give them an alternative that works, that they can afford, and they'll readily adopt it. This is a great example of a biological or ecological approach to pest management, and it's taking the insect's natural system, which is the female moth emitting this pheromone, just very few molecules, that the male moth is flying around, and once they cross this scent trail, then they can start to hone in on that moth and fly over there and mate. Once mating's done, the female lays the eggs on the apple, the eggs hatch, the little worms crawl out, burrow into the apple, and then we've got our damage. So if we can prevent this mating, we can stop a lot of the pest problems. And that's exactly what we do with the pheromones. We essentially flood the orchard with the same chemical, and the male moth can't find the female. It gets confused and flies around and dies, and that's the end of it. So kind of an innovative approach that's really hit the sustainability mark pretty nicely. The kinds of reductions we're seeing, 85% reductions in our organophosphates, that's significant, that's huge. That's a lot of pesticide not going into the environment, a lot of people not getting exposed to it. In some cases, we do see improved biological control of other insects, but some insects are worse. So again, here's a trade-off. It's not a perfect solution, and generally it's not a standalone solution. We still need some other controls. But another part of it is generally this system is more expensive for the growers. It's a great example of, okay, if the consumers are saying they want these kinds of changes and they cost more, how do we build incentives through the marketplace so that growers can afford to make these changes? And the Food Alliance is one example, organic is another example. So we do have examples of ways that the consumers can vote with their dollars for these kinds of sustainability changes. Another example that points out the complexity of trying to figure out some of these biological solutions. Another example from apples. Replant disease is actually a common disease for a lot of perennial crops. You grow a perennial crop for a number of years, you pull it out, and then you go to replant it, and all of a sudden it won't grow. And it has to do with the fact that the root system of that perennial crop changes the microbiology in the soil, and it often over time leads to a buildup of disease organisms that flourish on that crop. Well, once the crop is established, they can kind of coexist. They have somewhat of an equilibrium. But you come in with a new young apple tree and you stick it in this soil full of apple disease, and it doesn't have a chance. So in the apple system, this is a big problem because typically people aren't going to rotate out of apples into wheat and watermelons. They're going to plant apples again. That's what they're set up to do. Their environment is good for it. They want to come back and plant apples. And we are seeing apple planting cycles get shorter and shorter as the lifespan of varieties gets shorter and shorter. So Red Delicious were good for 50 years. Gala might be good for 15. Now we're going to see a lot more replanting in our state. Therefore, we've got to figure out a way to solve this problem. The standard process in the past has been fumigation of the soil, and it was generally with methyl bromide, which was an ozone depleter. So that's out. That's actually banned now for most agricultural uses. There are other soil fumigants. They're not great things to be using on the soil all the time. So we need some biological alternatives. And you can see the impact of this particular problem in this photo, where here is an apple tree planted back into the orchard where they had removed the trees the previous year. They tilled it up. They hadn't done anything else. They didn't fumigate the soil. Planted the tree back in, and you can see this little bit of growth. Here's a shovel. 12 feet away from this tree, they added a row to the orchard that never had apples planted. That soil had never experienced apple roots. And that's this tree. And here's the shovel. 1 year, 1 year. This is a dramatic impact. So think about the economics. If you've got 15 or 20 years of no growth, you're out of business. You are not economically sustainable if you don't control this disease. So what can we do? This shows you what happens to these poor root systems. Here's the roots, apple roots in soil that's never seen apples. 1 year of apples, 2 years of apples. After the third year of apples growing and you come back in, those disease organisms just eat the roots alive. They're not going to get treated. A researcher in Wenatchee, with Mark Mazzola, decided to try growing wheat as a cover crop before apples and see what that would do in terms of changing the soil biology. And sure enough, he was able to first find what the microbial shift was once you planted apples, and then he was able to find out that wheat more or less reversed it. But it wasn't just any wheat. It was specific wheat varieties had a much bigger effect than others. Some had no effect. And you can see that here, where here's the apples planted back into this replant soil with no treatment. They didn't grow. Here's apples planted after a cover crop of Eltan wheat, rye wheat, and Panawalo wheat. And the varietal differences were pretty dramatic and really surprised me. So in terms of making recommendations then, as we're trying to get into some of these biologically based practices, which we think are going to help our sustainability, I can't just tell a grower, plant wheat before apples. We need to know which kinds of wheat. It makes a big, big difference, and it's much more complicated. Our need for information, I'm going all over the place here, goes way up as we get into these biological solutions. Now let's touch on organic farming for a minute. Organic farming is well known in terms of prohibition against using commercial pesticides and fertilizers. Those are the two big things most people